All right, I'm live with 52 weeks of AWS, still covering the AWS Developer Certification, which is a great certification for people wanting to prove they know how to build stuff on AWS in a software sense. And I'm going to go ahead and get right into it, into DynamoDB. And I'm going to share my screen and talk about this in detail. So really to dive into this, DynamoDB is a pretty cool database, and there's a growth in unstructured data. And just people are talking about the fact that unstructured data is growing something like 40 to 60% every year. Things like rich media, audio, IoT data, like you name it, people are using unstructured data. So there are some limitations to using traditional relational databases, which were built in, let's say, initially papers around relational databases were from the 1970s. So what is DynamoDB? Well, a few things to be aware of is it's a fully managed system. And what that means is that it is a database system that is able to create a table. You can put a utilization for it. It's a fully managed service that'll scale up and down. You don't have to worry about setting up distributed computing. It's all done for you. It also has consistent and fast performance, so like millisecond level performance when servicing it, and making a request or putting things in there. There's access control as well, so you can set up things with the IAM system here to let different people in your organization use it in a different way, and it's flexible, right? You can use things like the console, you can use the SDK, right? So it's a very user-friendly database. I find it to be probably my favorite database to build solutions on AWS because it's just so quick. Now, in terms of the use cases, a good one is Duolingo. I've actually used it before for Portuguese. Obrigado, right? Say thank you in Portuguese. I've also used Spanish, gracias. Right? I've used the app itself quite a bit. And DynamoDB has 31 billion items, right? Because they're building this thing for all these different languages. And some of the use cases for Duolingo were, serverless web apps, microservice data, mobile backends, ad tech, gaming, right? These are all good use cases for using DynamoDB. A lot of startups that I've worked at use DynamoDB. So what are some of the key concepts of Dynamo? Well, the first thing to be aware of is this concept of a table, right? That's really like a spreadsheet in a sense, at a very simple level. And there's items inside of the tables, and these could be zero, or there could be, who knows, thousands of items inside, or millions of items. And then the attributes is each item, basically each item is composed of one or more attributes. So these would be like the fundamental data element. And then there's a primary key that would uniquely identify things. So no two items should have the same key. That's one key characteristics of something like DynamoDB. There's a couple different kinds of keys as well. With DynamoDB, there's a single primary key. So this would be a partition key only. And in that scenario, you would build an unordered index on the primary key attribute. Then there's also a composite primary key. And this would be something where it's composed of a couple attributes like a partition key and a sort key. And then Dynamo would build up an unordered index on the partition key attribute and a sorted index. And so really the big takeaway here is that DynamoDB is a key value store and a document store. And so you just choose what scenario you want to use it in. Now, in terms of DynamoDB, it has some unique things as well. So like, unlike a relational database, Dynamo doesn't have to have a predefined schema. That's really a huge advantage for many scenarios. Things like game data, for example, or metrics for a sporting event or something like that. And so if we look at an example of what that would look like, there'd be a JSON data structure, and inside there would be scalar types like number, string, binary, Boolean, null, multi-value types like string set, number set, binary set, or even list and map. And each of the items can have a maximum of 400 kilobytes in size. So let's talk about partitions and data distribution, which is one of the key reasons to use something like DynamoDB is it can scale automatically. So Dynamo will store the data in a partition, and that's really an allocation of storage for the table, and it has SSD backing. So in the old days, before there was solid state drives, this was a huge problem. The disk drive was in relational databases in particular was just really a problem. And so you'd have to have like really high memory machines. Now that we have SSD and we have key value based systems, we have really great performance. And if your table in Dynamo is a simple primary key, then Dynamo will retrieve it based on a partition key value. And the partition key of the item is also known as a hash table. So, in a sense, it works like a Python dictionary, right? A Python dictionary has O to the one um, uh, big O notation. What that means is that if there's 5 items or there's 5 million items in a Python dictionary, you'll always get the same response because you just do a key lookup. You just say, does this key exist? And it says, yep, it does exist. And so this is one of the advantages of using a key value store system. On the flip side, if the table has a composite primary key, this would be a partition key and a sort key, then Dynamo would store all the items with the same partition key value close together and then order them by the sort key value in the partition. And the sort key of an item is also known as the range attribute. So here's a good example to talk about is, let's say you had a pets table and there's a simple key and it spans multiple partitions. The DynamoDB system itself, the engine, would calculate the hash value of a partition key to determine which partition should contain the item. So it's all happening, but really behind the scenes. And then it's based on the hash value of the string dog, and the items are not stored in a sorted order, right? And that's one of the advantages of it. But let's say you wanted to have a pets table that has a composite primary key that has, let's say, animal type, which would be a partition key, and there's a name with a sort key. So Dynamo again would calculate the hash value of a partition key to determine the partition that should contain the item. And in the partition itself, there'd be several items with the same partition key value. So Dynamo would store a new item among other items with the same partition key, and then make that in ascending order by sort key. And in reality, Dynamo that would then write an item with a partition key value of a dog and a sort key value of Fido in ascending order. And so that's really the basics of Dynamo. But let's talk a little bit now about secondary indexes. Dynamo allows you to have fast access to items by specifying the primary key, but there's also places where you would want to have one or more secondary, basically alternate keys available. And one way to do that is by having a secondary index on a table. So it's like a lookup. You already have the metadata about what's happening in the system. So how would we do this? Well, one of the ways to do this would be to have a secondary key that's enabled, and this would allow you to perform queries on attributes that are not part of the table's primary key. So a secondary index would let you query, for example, data that's in the table by using an alternate key. In addition to the alternate key, though, you could also have a subset of other table attributes. So you could specify what are the kind of attributes you want to copy, and basically customize it for your use case. And there's a couple different ways to do secondary indexes. There's a global secondary index, which is an index with a partition key and a sort key, both which are different than the base table. And a global secondary index is considered global because the queries can span all the data in the base table across all the partitions. And a global secondary index has no size limitations, and it's provisioned through settings for read and write activity. So really you can control, how that actually works in terms of, the resources it uses. There's a local secondary index, which is option 2, and that's an index that has the same partition key as the base table, but it's different sort key. A local secondary index is local in the sense that every partition of a local secondary index is scoped to the base table. And so what this means is that the total size for an index item for any one partition key can't exceed 10 gigabytes. And also a local secondary index share would need to be provisioned through settings for the read and write activity with the table it's actually indexing. So in a nutshell, every table in Dynamo has a limit of 20 global secondary indexes and then 5 local secondary indexes per table. So depending on what it is you're trying to do, you would use a combination of both. And in fact, if you had, for example, 20, global secondary indexes, you may then want to go into the local secondary indexes and also start to supplement what you're doing in a huge, scenario where you have lots of use cases for secondary indexes. Another example of a secondary index would be a music table where you query items by an artist. You can't do this query with a music table if you wanted to look at genre and album title or something like that. And so you could create a global secondary index on the genre and the album table from the music table. That would be a good example. And one other thing to note is that if there's a combination of the genre and album title that aren't unique, that could be an issue. And so multiple albums can actually belong to one genre. So this is where you would query by the artist and the album title, and you'd create a local secondary index called artist album title from the base music table. And the local secondary index would have the same partition key as the base table. So let's talk a little bit about read and write throughput when building things with DynamoDB. And a few things to be aware of here are that Dynamo will automatically replicate across the availability zones. Again, availability zones are essentially isolated parts of AWS. There's in a geographic region, there's multiple availability zones. And so Dynamo can automatically have support for this. And because it's eventually consistent, which means that it can handle, basically high load or failure, eventually everything will kind of sort itself out. And as a result, it has eventually consistent reads. So when you read data from Dynamo, it initially may not reflect all of the write operations, but if you query it a few times, eventually it will. And then it also has strongly consistent reads. So if you needed to, every time you query it, like on only the first time, need to have a strongly consistent read, you could tweak things so they could support that. So it really depends on which trade-off you want. Do you want like basically the ability to have really high throughput, or do you care about consistent reads? Because there's a trade-off. If you have consistent read, you're going to affect the performance a little bit. The Amazon DynamoDB transactions are really a pretty easy way to simplify developer experience as well. So you can do all or nothing changes to multiple items. You can have transactions that have, atomicity, consistency, isolation, durability, acid, right? Those are all available. Use cases would be like, the typical use case is finance, right? Like transactions, you want payroll or some kind of, ledger thing to go through. Also, a thing to be aware of is that you can also do provisioned throughput or on-demand throughput. Provisioned is actually basically ahead of time, you're going to say, look, I want to have this kind of capacity for my Dynamo system. And that's actually a pretty good use case for, applications where there's a really consistent workload. But if you do on demand, Dynamo can also basically automatically, elastically respond back to whatever it is that you're building, which is also a pretty interesting option. So on demand is a better option if you have new tables and you don't know yet, how many people are going to use it. You have, non-deterministic or unpredictable traffic, or if you prefer to only pay for what you need, right? Like you may not want to spend a lot of money. There's definitely use cases where you want to do the opposite. If you're going to do $1 million Super Bowl commercial, you probably do want to provision ahead of time. If you don't know yet if it's going to be successful or going to get a lot of traffic, the on-demand option would be a good option. So a few things to remember is, like, let's say you want to do, read 20 items that are 11 kilobytes in size every second with eventual consistency. How many RCUs do you need? You could say, I need 30. So you would round up the 11 kilobytes up to the next multiple. So say 12 divided by 4. kilobytes per RCU, which would be 3, multiply the items by read per second, which would be 60, divided by 2 for eventual consistency, and that would be 30, right? So there's a kind of a rule of thumb that you can use to figure out the number of RCUs necessary. And if you wanted to do 120 items that are 7 kilobytes in size every minute, how many WCUs, right? Write CUs do you need? You need 14. It would be WCUs require to write each 7 kilobytes would be 7. Number of items per second would be 2. Multiply WCU per item by items per second, which would be 14, right? So it's nice that you can actually have a little bit of back of the envelope stuff to figure out how much you would need for either the read compute units or the write compute units. Now let's dive into the streams and global tables. So a lot of applications can benefit from the ability to capture changes to items that are stored in Dynamo at the point in time when these changes occur. And so one of the ways you can do this is by enabling DynamoDB streams as a solution. A stream would consist of stream records. So a stream record represents a single data modification of the DynamoDB table. And the stream records are organized into groups or shards, and each shard would act as a container for multiple stream records. Dynamo would automatically then essentially split it out and spread that traffic across all the tables so that it would automatically handle everything that needed to be handled in terms of distributing that. And the global tables would be a fully managed solution for multi-region, multi-active database, right? So you can build global scale solutions with DynamoDB. And a global table is a collection of one or more tables called a replica table. So this is kind of a cool concept. You can have lots of tables. They all kind of work together here. And the global table would use the DynamoDB streams to essentially propagate the changes between the different replicas. But DynamoDB does not support the partial replication, though, of some items. So it's really kind of an all or nothing approach. Now, there is this concept of, in a global table, there would be conflicts, and this is typical in a distributed system. And so to achieve that, Dynamo uses something called last writer wins. So basically, Dynamo would make a best effort to figure out who is the last person that made an update. They'd look at, let's say, a timestamp, make sure everybody agrees, and that would be actually the way to choose what would be the winner in a multi-write situation with a conflict. A good example of how this would work with read consistency would be an application could read and write data to any replica, but if the application only uses eventually consistent reads and the only issues reads against one region, then there's nothing to do, right? It'll work without any modification. Now, strongly consistent reads, though, require using a replica in the same region where the client is running, and transactions are enabled for all single region DynamoDB tables. So this is a kind of a common pattern, actually, for even a traditional SQL database, right? Like you would have multiple read replicas, and people would potentially even be given a particular read replica because that are in one part of the country, and that actually scenario works out very well. All right, let's talk about backup and restore. This is always a big one, right? How do you actually deal with backup and restore? So one of the things you can do is have on-demand backups. So Amazon DynamoDB provides this concept of on-demand backup and restore, which is amazing, right? You can create a full backup so that you're gonna rest at night. You also have the concept of point-in-time recovery, which is pretty neat as well. So you can actually recover from maybe like an accidental write or delete operation. So you don't necessarily, with a point-in-time recovery, have to worry about the creation, maintaining, or scheduling of on-demand backups. Let's talk about some of the basic operations for tables. So some of the things that come up quite a bit with DynamoDB would be control operations. This is when you would go through and create or manage DynamoDB tables. There's also data operations, like you would perform, create, read, update, delete, CRUD operations. There's batch operations, which would be like a stream to the table, for example, transactions, the all or nothing kind of transaction with the API. The create table is a pretty cool one because it allows you to do an async operation, right? So you're not locking the thing up. You're asynchronously writing a bunch of data. The Boto 3, the AWS SDK for Python, is a great way to do that. I personally use Boto 3 with Dynamo. I think it's a really great tool. The put item operation would create a new item or replace an old item with a new item. And so this would be a good thing to use if you want to actually just do updates. The update item operation allows you to update an existing item without doing a bunch of back and forth things. And again, very easy to do in Python, right? Table.update item. And you just update the particular key value pair with a dictionary style update syntax. The delete item will allow you to delete an item in a table by using primary key. So again, primary key is critical. The put item, update item, delete item, you can also do a condition, right? So you can match some kind of condition. Also, the get item operation allows you to retrieve a specific item from a DynamoDB table, right? Which is often, in the case of the fact that we know that each ID is unique, it's a great way to actually get specific data from DynamoDB. The query is going to be a little bit more expensive, but allows you to read only the items that match the primary key from a table or secondary index, and you could do a filter expression. The scan is really a fairly expensive operation where you could actually scan the entire table. Now, if it's a 1,000,000 row table, that's probably not what you want to do, but you can get paginated results from doing the scan operation. So to improve the performance and also the cost of what you're doing, you can also basically have the number of items returned by query or scan have a pagination result, or you can do a limit result like, hey, don't only show me this much stuff. You can also use batch operations to get like really high throughput as well. And then you can use DynamoDB transactional read-write APIs. So developing with Dynamo, some of the things I would recommend doing would be, creating a table. You can just do it right in the console, really easy, add some data, query it. And in general, I think the big things to take away with Dynamo are that there are, the introductory concepts, the key concepts like primary key. There's partitions, data distribution. There's secondary indexes. There's read-write throughput. There's streams and global data. There's backup and restore, and then there's the basic kind of Python operations that you're doing. So really, Dynamo, if you're a developer, I think you must use Dynamo, in my opinion. And I think a good way to use it is to use the Boto 3 API. And I would recommend doing things inside of Cloud9 so that you get this really good AWS experience. So try it out, see how you like DynamoDB. It's really, I think, a pretty cool tool, and it's great for building fast prototypes. All right, I will be covering next week CloudFront Elasticache, which is a pretty cool service that allows you to use caching, and we'll continue the AWS developer certification.